So sessions 3 is meant to cover image navigation. So this is the kind of stuff we need to know about ITK-SNAP before really getting into segmenting structures. Now, unlike the previous session, this one is meant to be interactive in a sense. Well, I mean, they're all meant to be interactive, but what I mean is for you to follow along with me through some of the demos and some of the examples. And then there will be a small exercise at the end. So after this session, what you should be able to do is load anatomical images and segmentations into ITK-SNAP using a couple different methods. So you can do it through the menu. There's also a drag and drop option that's quite convenient. You'll be able to change the appearance of anatomical images by adjusting contrast and using the color map. And we'll also, if time allows, talk about adjusting image orientation when the image header has incorrect information. So we'll try to cover quite a bit of material in this session. Although a couple of the later things, depending on how the time goes, we might have to skip. So loading images, using the 3D image cursor, zoom and pan, contrast adjustment, color maps, loading segmentations and overlays, adjusting opacity, measuring volumes. Actually, we'll go through all of these. The ones we might not get to are not on that list. Okay, so the first thing we're going to encounter is the image.io wizard, which is, and I'll have a little demo in a second, but if we just look for a second at what this wizard has, this is what the window that you use to load an image, and it has a browse button, which is going to bring up your system dialog for finding an image. It also has a history button, so every time you load an image, it gets added to the history, and so if you want to bring it back later, you can use the history. Another convenient use for the history is if you want to load an image in the same directory as an image you previously loaded. If you bring up that first image in the history and then you hit browse, the browse window should pop up in the same folder. So that's a useful way of using history. And once we select an image, ITK-SNAP is going to make its best guess at what the file format is. And it's almost always right, but sometimes with some formats you have to tell it. In particular with DICOM, because DICOM file names don't have an extension a lot of times. When you point to a DICOM image, it might you might have to tell it DICOM. So be aware of that little drop down. So let's go ahead and do a little demo. If I can break out of my. Okay, where did it go? Okay, so here I'm going to open ITK-SNAP, go to File, Open Grayscale Image, and I'm going to browse. And so now we all should have on our desktop an ITK-SNAP training folder. So I'm going to go to that folder. And now I'm going to go to Materials, Session 03. Let me just show it like this. Data, and then I'm going to go to the brain tumor folder, and I'm going to do this image, BRATS HG0015 T1C. So this is a set of images from a recent tumor segmentation challenge. This is a public data set. So once I've picked the file name out, you can see it told me it thinks it's a meta image file. So when I click next, oops, I clicked too fast. Sorry about that. So I'm going to open it again, and now I can see with the history I can bring the image back up. When I hit next, it's going to tell me a little bit of information about the image. And it might be hard for those of you in the back of the room to see this. Besides from the file name, it tells me the image dimension, the spacing. So the spacing is sort of the physical dimensions of each voxel. So this means the voxel is 1 by 1 by 1 millimeters in size. The origin, we'll talk later about what origin means. Orientation, some additional data size information. If we were to load a DICOM file, we would have a lot of all the patient information and other DICOM header fields in this list over here. So then we can click Finish, and there we have our image. So so far we just loaded an image, but let's keep going through the slides, and then we'll do some stuff with this image. Give everybody a second to have their image up. So here we're looking at the main window in ITK-SNAP, and let's just go over the different components of the main window. So first of all, we have the 3 orthogonal views. These are 3 cuts through the image volume from 3 different dimensions: a coronal cut, a sagittal cut, and an axial cut. We also have a 3D view, and in the 3D view we're going to see a rendering of whatever it is that we have segmented in this image. So we can, in this image, we have the tumor segmented in green, and the edema around the tumor segmented in red, and you can see those 2 objects being rendered in the 3D view. Okay, so then up here on the left we have the main toolbox, and this main toolbox contains 6 different buttons for different modes of interaction with the slice views. So there's a crosshairs mode, the one that's currently highlighted. There's a zoom mode. Ben, could you help out? Yeah. So we have the main toolbox allows us to select different ways of interacting with the image, and we'll be using the main toolbox all the time. So underneath the main toolbox, we have a tool options control box, and this one is going to change depending on what tool you've selected. So if right now we have selected the crosshairs tool, and it's showing us what is the intensity under the crosshair. But depending on the tools that we select, we're going to have different options showing up there. Then there is a box with different segmentation options, and we use this box to select which label to use for segmentation. We can also bring up label editor. We can do undo and redo. So that box really is something you're going to be using when you're doing segmentation. And finally, we have the 3D toolbox, which is different ways of interacting with just the 3D window in the lower left corner. So the 3D toolbox really applies to the lower left window. Finally, we have the menu at the top, where all different commands are that are not on the screen itself. One other thing that I didn't highlight here is that underneath each of the slice windows, there's an additional kind of context panel with some buttons. Usually it just says zoom to fit, but sometimes different buttons show up there. So there's some other, and these are commands that really apply to just that specific slice window, not to the whole program. So that's kind of the layout of the main window. And we'll start talking about the 3D cursor. So as I mentioned before, SNAP shows 3 orthogonal cut planes through an image. And the point where these 3 cut planes come together is designated by the 3D cursor. So if we look at any one of these slices, you see there's this kind of blue crosshair going horizontally and vertically. And so each one of those crosshair lines, think of it as there being a slice like this and a slice like this coming out of plane. Okay, so as if you were looking at this 3D picture head on, right? So you have the blue lines represent those slices that are sort of coming out of the screen. And as we move the 3D cursor in one of these view planes, we're going to be sliding these slices back and forth in the other view planes, and I'll demonstrate that. So, okay, so this is just a blow up of what the cursor looks like. So there are 4 different ways of navigating around the 3D image in ITK-SNAP. 2 of them can be thought of cursor repositioning. So we can move the cursor in and out of the plane in the current view. And we can move the cursor in plane. And then we can zoom and pan. And now I'll demonstrate these. So we're going to demonstrate each one of these modes in this kind of setup, where on the left side I have a representation, three-dimensional representation of an image with a particular slice picked out. And on the right we have what snap looks like. And so in these pictures I'm going to be only concentrating on this top left coronal slice. So as if whatever operations I'm going to be performing, I'm performing them in this window. And I'm going to see how these operations relate to the three-dimensional space. Let me see if I can take some of these lights down. It's too dark. Is that easier to see like this? Okay. So you can see there's, in this three-dimensional view, I have a very kind of translucent view of the other 2 slices, the other 2 orthogonal slices. Okay, so first let's look at the out-of-plane navigation. So what I mean by out-of-plane is just changing which slice is shown in the window. So we can change the slide. So if you look at the window, the slice shown in the window changes, and in the other 2 windows the cursor moves because we're now looking at a different slide. So that's out-of-plane navigation. In-plane navigation is moving the cursor in the slice plane, which is not going to affect the slice itself, but it's going to affect what's shown in the other 2 slice windows. So as I'm moving the cursor in the slice, the position of the other 2 orthogonal planes follows the cursor, and so the other 2 windows are showing different slices. Then there's this concept of zoom. So the window doesn't always show the entire slice through the image. What we see here is actually just a kind of a little window focusing on a portion of the entire slice. And so when we were zoomed in, we can change the zoom factor. So we're making that little window cover a smaller portion of the slice. And on the right, you see we're zooming into the image, zooming in and out of the image. And finally, there's a pan operation, which slides the yellow window, the viewport, around the slice that's available in the entire image. So we'll demonstrate those in a demo very quickly. Or maybe, why don't we just go ahead and do the demo, and I'll talk about these things. Okay, so first of all, let's look at the out-of-plane navigation. So if you can see where my mouse cursor is, there is a scroll bar, and by clicking the scroll bar, I can click through the slices in that view plane. I can also do the same thing with my mouse wheel, and I can also do the same thing, at least on the Mac, I can do that with the 2-finger scrolling motion on the touchpad. So you can see I'm changing the slice and my cursor is moving in the other 2 slices. But this 3D cursor is always allowing me to sort of view one place in the image in all three planes. So if I want to look at the hippocampus, I can see the hippocampus in all three view planes at the same time. So now what I'm doing is I'm moving my cursor in plane by using my left mouse button, and the image in my current window doesn't change, but the images in the other windows do change. So the cursor is really used for selecting a location in the image that you want to view in all three windows. I want to look at the ventricles. I'm going to click on the ventricles, and now all three of my views are on the ventricles. I want to look at the tumor. I click on the tumor, and now all three of my views are looking at the tumor. So the cursor is really, if you want to kind of get a idea of what a particular location image looks like in 3 dimensions, click on it with a cursor and you will see it in all 3 orthogonal views. So the zoom functionality is activated by clicking this zoom icon in the main toolbox. So up here in the top left, the little zoom icon, if I click on it, now my left mouse button is going to pan. So by holding down and moving my left mouse, I'm just panning my image around. My right mouse button is going to allow me to zoom. As soon as so holding it down and dragging allows me to zoom in and out. As soon as I zoom in, a little sub-window shows up on the bottom left corner, which shows me my entire image, and the little white box is showing me the region of it that I'm focused in on. So I can also pan by using this little white box. So I can just pick up this little white box and move it around and pan that way. And then I can, if I don't want to be zoomed in anymore, I can click this zoom to fit button and things are going to come back to the original zoom factor. Okay, so while you're practicing this, let me skip a couple slides and just show this slide so that it's very clear. So for moving the cursor, we use the crosshairs tool, which is highlighted there. The left mouse button gives us in-plane motion, and the mouse wheel gives us the out-of-plane motion. In the zoom pan mode, the left button pans, and the right button, holding it down, moving up and down, zooms. So, so for the rest of this session, if something is not working on your laptop, if you could just raise your hand, and we have a couple folks here that can come up and help. Okay, so I'm going to mention a couple more details about zooming and panning. So when we're zooming in ITK-SNAP, there are 2 modes that are available. You can have either the same zoom factor in all 3 windows, or you can have each window having its own zoom factor. The second option, I call it linked zoom. In other words, all the windows have the same zoom. If I zoom in 10 times on the coronal slice, I'm also zooming in 10 times on the axial slice and on the sagittal slice. And this is natural because you're sort of looking at the same data from 3 different viewpoints, but the scaling is the same. But sometimes you want to only zoom in on one view, and you can select those. I'll show you in 1 second how to do that. And also to mention, how do we describe zoom in ITK-SNAP? So it's zoom is measured in screen pixels per millimeter. So in other words, how many pixels on your display, not image voxels, how many pixels on your display fit into 1 millimeter of physical space. So this is 1 millimeter in your subject's head, and how many pixels there are. So if we really zoomed out, we might have 1 pixel per millimeter. If we really zoomed in, we are using 20 pixels to represent that 1 millimeter. So, and the reason we use this measurement is that our voxels might be anisotropic. So, we might have a voxel size 1 by 2 by 5 millimeters. And if we try to describe zoom related to the voxel size, it would be inconsistent between views. But this is screen pixels are always sort of more or less isotropic.
Voxels means the 2D surface or the space?
No, the voxels are three-dimensional voxels in your image volume.
It's in the image or it is in the volume?
So the voxels are in the volume, but the pixels I'm talking about are on the actual, like on your display. So now let me go back to my snap and just demonstrate this. So I know again in the back it's very hard to see this, but there's this view zoom views together option on the zoom pan tool options, and if I turn it off, then I can zoom in one of the windows and zoom out in another window. But if I click zoom views together, then as I zoom in one window, all of the windows zoom in at the same level. And so once you select that option, then we have this zoom level that we can input. So we can specify exactly what zoom we want. So, I might want 10 pixels per millimeter. And so each one of my...
It's not going to be. You want to zoom the whole screen. It's a universal access. You can turn it on.
Oh, okay.
And you can actually use the keyboard and just zoom the whole. Oh, okay.
All right. Okay, and then there's also a button to reset all views here. Reset all views. Okay, so, and we'll have a chance to experiment with these different zoom options later on. So next I want to talk about a different topic, and that is adjusting image contrast and how images are visualized. So first of all, a lot of times we'll have images that when we first load them in an ITK-SNAP, we're going to have very poor contrast. I mean, this is a bit of an extreme example here on the left, but I can have an image where I really can't tell between different tissue types in the image, and that's because the screen can only show 256 shades of gray. Our eyes can't even tell that much apart. I think it's something like 60 shades of gray that our eyes can tell. So if the range of intensities that are of interest in the image doesn't map to the entire dynamic range of our eye, we're not going to be able to perceive contrast between structures. And what we can do is modify the contrast so that the contrast between the different tissue types is as great as possible, and that's going to help us view the image, and it's definitely going to help us with the segmentation. And so ITK-SNAP has an image contrast dialog. You can bring it up by on Windows by pressing Control-I, and on Mac by pressing Command-I. And so if we examine this dialog on the left-hand side, there's a list of image layers. Right now we only have one image layer loaded, the main and anatomical image. On the right, there are a number of different components in this window. So the very top there's window and level, and this is kind of simple contrast adjustment. In most cases, this is all that's necessary to just adjust window and level. And notice that there's a auto button there. That auto button really works 90% of the time. All you have to do is just press the auto button. There's even a shortcut, Alt-I, that seems to only work on Windows for some reason. It does that. Then if you want more fine-tuned control over your contrast, what you have here is a graphical representation of the mapping between input intensity, so the actual numbers stored in the image data, and output image intensity. That's what's shown in the display on your screen. And you can play with that function, modify the parameters of that function. Underneath that is shown the image intensity histogram, which can be useful when you're fine-tuning your image contrast. So let's look at the basic window and level contrast adjustment. So what I'm showing here in yellow is the intensity transfer function. So it maps the raw image intensity on the x-axis into the visible grayscale level on the y-axis. So in this case, everything that's below, all the intensities to the left of the first dashed line are going to map to value 0, which is, as you can see on this gradient here, maps to black. And everything to the right of the second line, dashed line, is going to map to white, or 255. And in between these two dashed lines, intensities in between those two dashed lines are going to map linearly between 0 and 255. So in the ITK-SNAP notation, level is the value of this first intensity, so the intensity below which everything is mapped to 0. And window is the size of this interval where the mapping is linear. So the intensities that you're going to be able to tell apart lie between level and level plus window values. So here's an example. So in this case, the image intensity perhaps is between 0 and 1500, let's say. So the input image intensity starts at 0, goes all the way to 1500. Our level value is 500. So everything below 500 is just mapped to black. The window level is 600. So everything between 500 and 1100 is visible, and then everything above 1100 is mapped to white. And the mapping is linear in between. And you can see in the histogram, sort of this is the range of intensities where there's a lot of intensity in the image. And typically we want sort of this window that we're making visible to overlap with the largest part of the histogram. So a lot of times we'll have some very bright intensities. There are very few of them, and we might have some variability in the background, and we don't want to use up dynamic range for either things that are very, very bright or very, very dark. We really want to focus on the relevant intensities in the image. So just again demonstrating this example, so if we look at voxel here, which has intensity 1300, it's being displayed as white. Voxel here, which is intensity 400, is being displayed as black, and the voxel 800 is being shown as gray because it falls inside of this window. So in addition to linear contrast adjustment, we can do nonlinear contrast adjustment. And this allows us to really kind of maximize contrast within parts of the input intensity range. So here this is being demonstrated. So in this case, the range of intensities between this control point and this control point maps to roughly the first half of the grayscale space, and then next, this smaller range of intensities maps to the second half of the intensity range. So we're kind of allocating more of the visible intensity range to this part of the image than to the part of the image to the left. In addition to contrast adjustment, so far everything we looked at was shown in grayscale. We can actually change the color map that's used to represent the image. So if, here we showed kind of input intensities being mapped to a range of grayscale values, we can, instead of using a grayscale color gradient, we can use different other color gradients, like different hues, or going from dark to red to yellow, and there are a number of different color maps. So that again can help us sort of increase the contrast in the image. So in the color adjustment window, there are a number of presets, but we can also design our own color maps. And now let's look at all of this in an actual example. So I'm going to bring up the image contrast, still working with the same image we had before. I'm going to bring up the image contrast window. And first, I'm going to click here, Reset, so that right now my level is set to 0, and my window is set to 2592, which is the entire range of intensities in my image. I can't really see the histogram right now because there's so many background voxels in the image that first peak on the left dominates my entire histogram. So what I can do is in the histogram options, I can change my cutoff. I'm only going to cut off the histogram at 5%. And now all of a sudden I can actually see the histogram. And so I can see that 99.9% of all my intensities really fall within the first 2/3 of the intensity range. And when I click the automatic button, that's the algorithm that SNAP uses. It tries to set the level in Windows so that 98, so that basically goes to the 98th percentile. So the last 2% of intensities are all mapped to white. And that typically works very well to give us a very good contrast within the image. But I can change the level value by hand, so I could change it to 1500, let's say. Or I could also do this by dragging these control points. If I drag these control points, it's just changing the window, the first or the last control point. If I move the control point in the middle, now I'm starting to do this kind of curve-based intensity adjustment. And I can add more control points. So in this case, I have this large peak of intensities, and I might want to allocate as much of the visible intensity range to that sort of large peak. So you can see I'm doing kind of a nonlinear mapping that really gives the most intensities to this peak in the middle. And as you can see, I get a very nice contrast between gray matter and white matter this way.
How did you find the point?
There's a little plus here, plus minus. Plus adds a point, and minus deletes the currently highlighted point. So now I'm going to click over to the color map, and here it's pretty simple. I can just go through the list of different color maps and choose the one that I would like to use. Or I can even edit the color map, and you get live feedback as you're editing it. Okay, so I'm gonna move on to the next topic, which is working with segmentations and overlays. So once we start working with segmentations and overlays, we're working with more than one image layer. So far, we were only working with one image layer. So in order to load a segmentation, we first have to have an anatomical image loaded. And the segmentation has to be an image of exactly the same dimensions as the anatomical image in SNAP. Once we load it, in order to visualize it, because we have different layers on top of each other, we need to adjust the opacity of the segmentation, transparency of the segmentation. Otherwise, we're not going to be able to visualize it effectively. So when viewing segmentations, there are a couple important elements in the user interface. Over here, under the crosshair tool options, we're going to see the label that's under the crosshairs, the label that's under the cursor. We'll have the description of the label under the cursor. Further down in segmentation options, we have a slider that gives the opacity of the segmentation, how transparent it is. And underneath that, we have a button for the label editor that lets us change the colors and the names of the different labels in the segmentation. So if we click that button, we're going to get a label editor, which is a simple GUI for renaming labels and changing their colors. So we can change the color, we can change the opacity. Another thing that we can do with segmentations is measure the volume of the segmentation. So there's a volumes and statistics window that we can get through the menu that's going to give us the volume for each label. In other words, the total volume of all the voxels that are assigned the edema label, the total volume of all the voxels assigned the tumor label. We also get the statistics of the anatomical image. So we can get the mean intensity for the tumor in the anatomical image, mean intensity for the edema in the anatomical image, as well as standard deviation. Overlays, again, like segmentations, can be loaded on top of an anatomical image. We can load any number of overlays. When we work with overlays, it's very important, again, to set up transparency well, because if we just load an overlay on top of an existing image, we're going to hide the first image. So in order to visualize them effectively, we need to change color maps and play with the opacity. So one thing we can do is, in the color map editor, we can make a portion of the color map transparent. So the y-axis in this little color map picture here is the transparency. So what we've done here is made the first portion of the color map semi-transparent up to this position, that's up to this orange place in the color map. And what that's going to do is to make only, I have here an overlay, but only a portion of this overlay is visible. Only the bright intensities in the overlay are visible. And the darker intensities in the overlay are see-through. And this is really good for showing statistical maps, things like that on top of images. Okay, so let me go ahead and demo some of this stuff before going through more slides. So I'm going to go to my image contrast. I'm going to just reset everything, because I'm going to reset my color map to grayscale. I'm going to reset my contrast to automatic. And now I'm going to load a segmentation. So I'm going to go to segmentation, load from image, and the wizard comes up. It's a familiar wizard, except for it says select the segmentation image to load. I'm going to click browse, and now I'm going to select the image that's called Bratz HG15 Truth. That's the manual segmentation for this image. Once I selected it, click Next, and click Finish. So once I've done that, the segmentation should show up. The first thing I can do is change its opacity by using the slider on the left. So I can make it completely opaque or completely transparent. I also have keyboard shortcuts for this. These are really useful. S is going to toggle my segmentation. So just hitting S is going to make segmentation appear and disappear. And A and D keys are going to make it a little darker, a little more and less transparent. So right now I'm using my A and D keys. And this is all in your, in your handout there's a list of shortcuts, so you don't have to memorize this, it's all listed there. I can render my segmentation in 3 dimensions by hitting the Update Mesh button at the bottom of the 3D window. We'll talk about 3D visualization later. And I have my label editor that I can bring up by clicking the label editor button. And here I can go in and assign names to my labels. So I just click on my labels and I give them names. And I can change their colors as well. Now, to measure the volumes, I go to Segmentation, Volumes and Statistics, and here I have the volumes, and I can see that the mean intensity is 597 for edema and 1108 for the tumor. Okay, so now let me load an overlay. I'm going to go to the Overlay menu and select Add Grayscale Overlay. I'm going to browse, and now I'm going to select the flare image as my overlay. Okay, so right now I don't see anything particularly changed, and it's because both the original image and the overlay are shown using the same grayscale color map. So what I'm going to do is go to Overlay menu and go to Layer Inspector. The familiar Layer Inspector comes back up. And if you look at the left panel here, now the image layers lists 2 layers. I have the main image and I have the overlay. And I can flip back and forth between them. So I can adjust the contrast for the overlay. But more importantly, I can click to the color map and choose a different color map for the overlay. So I'm going to select hot for my overlay. And also, I would like to make part of the overlay transparent. So first of all, let me make my segmentation more hidden. I'm going to hide my segmentation because right now it's hard to see anything. So I'm going to take these control points in the color map and I'm going to slide them down . Oops. And little by little you can see parts of the overlay image disappearing. Now there is a bit of an interaction here between contrast and color map. In the next version we're going to make this a little bit more intuitive, but right now you kind of have to play with the contrast as well as change the color map to sort of achieve this kind of effect of a semi-transparent overlay where only a portion of it is highlighted. So it gets a little busy with the colors if I try to show an overlay and a segmentation and an image underneath, but it's kind of doable. How are we doing with time? All right. I'm going to wrap up to give you a chance to do the exercise that we have. So I'm going to skip through a couple less important points. So I'm going to skip through some of the slides here and get you all to do the exercise for this session, which is 3A. And if we, you can find it at the first red little insert in your handout there. I just wanted, for those of you interested in some of the more advanced features, take the next 10 minutes to talk about them. So one of these advanced features is working with the understanding the anatomical space of images and doing some manipulations. And so we already mentioned that the metadata in the image header describes how voxel coordinates map to anatomical coordinates. And this picture just tries to kind of show this. So we have a voxel space where the coordinates are columns, slices, and rows. And we have an anatomical space where the coordinates are related to the scanner coordinate system and to the patient who is inside of the scanner coordinate system. And the views in ITK-SNAP include some of this information between how the image fits into the anatomical space. So there are two pieces of information that you see. There are these rulers. There are these rulers that measure distances, right? These little green rulers that measure distances. And there are these anatomical markers that tell you where is right, where is left, where is posterior, where is anterior, where is inferior, where is superior. Okay, so these little markers and these little rulers are only going to be correct if your image header has the right information. So it reads the metadata from the image header, figures out how this columns and rows and slices relate to anterior, posterior, superior, inferior, right, and left, and then shows you those labels and shows also the distances. Sometimes that information is not correct in the image header, and we need to fix it. Before I get to that, there's quite a bit of information about this mapping from coordinate space into the physical space, and you can see a lot of that information on the information tab. So in the same window where we looked at contrast and color map, there's an information tab, and you can see there are the dimensions of the image, the voxel spacing, that's the physical dimensions of the voxel, the origin. Now what the origin is in ITK-SNAP lingo is the position of the very first voxel in physical space. So it tells you what are the physical coordinates of voxel with the index 0, 0, 0 of the center of that voxel. And then the most tricky is this orientation code that appears over here where my mouse cursor is. So this orientation code is a 3-letter code. In this image is LAI, and LAI stands for the voxel X coordinate going from right to left, voxel Y coordinate going from posterior to anterior, and voxel Z coordinate going from superior to inferior. So that little 3-letter code comes from the image metadata, from the image header. Those pieces of information also allow us to tell you what are the coordinates of the crosshair in both voxel coordinates and in physical coordinates. So as you move your crosshair around, you're going to see in this info window there's the X, Y, and Z coordinates of the cursor. So this is saying you are in column 77, row 113, slice 85. Over here you have the physical coordinates, or the world coordinates of the cursor. Again, this is based on the image header information. And in these coordinates, by convention, x goes from right to left, y goes from posterior to anterior, and z goes from superior to inferior. That's the nifty convention. This is getting a little deep. There's a nifty convention and there's a DICOM or ITK convention, which has a different order of the axis. Yes? So nifty, DICOM, meta image have this information in the header. Analyze is a little is a little unreliable, to say the least. So I would go with nifty, DICOM, or meta image. Now SNAP is always going to have this, even if the image header doesn't have the information. SNAP is going to assume some default, and so this is what happens a lot of times if you use legacy image format. This information will be incorrect, and it will need to be corrected. So there is a reorientation dialog to correct this information when it is not correct. And what you do in this reorientation dialog, on the left it shows you what is the current 3-letter code. And you know, it might be that before reorientation things look like this. So something that should be inferior is actually mapping to left, and something that should be right or left is mapping to interior. So you would go and type in the right code, and then after you hit apply, the little letter codes should match up to the actual anatomy. Now, of course, this doesn't help you solve the left-right problem. So in this case, A stands for that the x-axis goes from interior to yeah, so it stands for A, that x-axis goes interior to posterior, superior, and left. So yeah, the left-right flip is something you just can't. If the header doesn't have that information, you know, it's a difficult issue. So yes, it shows the original orientation, and you can put in correct orientation. So again, this is something that you need to deal with if your header data is not correct. But we'll leave that. We'll skip the demo because hopefully most of you won't have to deal with this. But just be aware that that functionality is there. The other topic I wanted to touch on very quickly is working with multiple ITK-SNAP sessions. And in MR in particular, but in other fields as well, it's frequent to have multiple scans of the same subject with different sizes and orientations. So we might have a T1 image of this brain, which with whole brain coverage and the axial orientation. We might have an oblique scan with sort of different orientation, different size, etc. So SNAP allows you to look at these images together, but you can't load one as an overlay on top of the other because their dimensions don't match. Instead, what SNAP lets you do is work in 2 parallel SNAP sessions. So you would open the T1 image in one session, you would open the T2 image in another SNAP window. And the cursors are going to be linked between these 2 windows. So if I click on the hippocampus in one window, it'll point the cursor in the same location in the other window. And this is very useful for working with multimodality MR data sets. And the way that the cursors are linked is based on this coordinate system. So each image has a metadata that says how its voxel coordinates map to physical coordinates, and so it uses those physical coordinates to position the cursor in each space. In order to use this, the easiest way is when you're in one ITK-SNAP window, just go to the File menu and say New ITK-SNAP window. So that'll launch a second window. And you have to make sure that the options for multi-session cursor are turned on. Otherwise, the cursors will not be linked. And you can also turn on multi-session zoom and multi-session pan, in which case, as you pan in one window or zoom in one window, the other window will zoom as well. One thing that could happen is that if you have a lot of sessions open at the same time, you're going to run out of screen space. So there are some helpful buttons that you can use. So for example, each slice view has this little plus button, You should all see it on your screen, and that's going to blow up that slice view to take up the whole screen. It also has a little down to the left arrow. What that's going to do is collapse the whole snap window just to that slice. So so the rest of the GUI is going to disappear, and you're just going to see that slice. And you can also hit the F3 key to hide all of the GUI elements. So, and you hit it again, they'll show up. So you'll lose the panel on the left, and then the panels underneath. You're just going to be seeing the image. So using these features, you can kind of lay out several snap windows on your screen at once. It's kind of convenient. So very, very quick. I know I'm probably eating into John's time here. I just want to show you a couple of these things. So I have included here a multimodal folder where I have a 3 Tesla MRI scan. So now I'm going to go into my menu, say new ITK-SNAP window, and I'm going to open the T2 scan from the same folder. And as you can see, the cursors between them are linked. As I move around in one, the other one moves around. And so if I want to reduce my space, I click those little left arrow buttons, and you can see I'm using a lot less screen space. And then there's the button shows up here at the bottom, so I can expand things back if I want to. And one last thing that I didn't show you that I wanted to show you is a nice way to work with the operating system to open images. So you don't always have to go through the dialog. You can also drop images on top of ITK-SNAP. So let me show you that, and then I'll stop. So I can go to my materials here, pick out a nifty image, and just drag and drop it on top of a snap window. And this works on different operating systems, not just Mac. And I get this little window that says, what do you want to do with this? Load it as the main image, load as segmentation, load as overlay. So I can say Linux and Windows as well. It does work. And then I can take my segmentation image and drag it on top and say load as segmentation, and it loads as segmentation. So it's kind of convenient not having to go through so many dialogues. It works for anything that Snap recognizes. Yeah, I mean any format that Snap recognizes. Nifty, yeah, it'll work with Nifty. DICOM, you can drag a DICOM file. I think, maybe the DICOM won't work. I'm not sure about that. Okay, so I'll stop. I'll just summarize that you can load images using Wizard, History, Drag and Drop. We covered navigation modes that include in and out of plane cursor movements, zoom and pan. We can adjust contrast in images, change color maps, adjust opacity, and we can view multiple images of the same subject, either using overlays or using multiple ITK-SNAP sessions, as I just showed you. So that's the end.